So let's try percent volume volume calculation. Listerine is a mouthwash. People probably have seen it in stores or at home. The product is marketed under the slogan, kills germs that cause bad breath. What is the concentration of ethanol in Listerine if a 750 milliliter bottle has 202 milliliters of ethanol? So in this case, I'm looking for the percent by volume. And I know that that formula goes, I need the volume of solute divided by the volume of solution. I'm going to times by 100%. Alright, so I know that Listerine bottle has 750 milliliters bottle. That's my volume solution. If it's got 202 milliliters of ethanol, that must be my solute. Volume of solution is in milliliters, volume of solute is in milliliters. I don't need to do any conversions. I can plug them right into my calculation. I'm going to have 202 milliliters divided by 750 milliliters and times by 100%. And I get 26.9. Whenever you quote these, you have to say what type of percent you did. Did you do a volume-volume? Did you do a mass-volume? Did you do a mass-mass? So this is my final answer. Alright. Sometimes concentrations are very, very small. For the very, very small calculations, we use an idea called ppm or ppb. This means parts per million or parts per billion. Alright. For parts per million, these are always done in mass. You take the mass of the solute, you divide it by the mass of the solution. Again, same idea as the last formulas. These units have to agree. Grams to grams, kilograms to kilograms, whatever it is, it has to be the same unit, which might mean that some conversions are necessary. For parts per million, you times 10 to the 6. Instead of, for percentage, we would times 100, which is 10 to the 2. Now we're doing times 10 to the 6. Parts per million is used for very small things. To give you an idea, if you think back over the last 2 years of your life, and if you can remember one single minute of it, so try to imagine 1 minute out of 2 whole years, that is 1 part per million. Similarly, part per billion is even smaller than part per million. Instead of doing times 10 to the 6, we're talking about times 10 to the 9, times a million, times a billion. Again, mass of solute, mass of solution, the units have to agree. 1 part per billion is the same as, what was that analogy? Let's imagine a roll of toilet paper that could span from New York City to London, England, so all the way across the ocean. If you imagine 1 square of toilet paper in that entire distance, you're thinking of 1 part per billion. Like I said, this is only used for very weak concentrations, very small concentrations. The word we use that is dilute. Alright, Perrier. Those are green bottles of sparkling mineral water. Its label says it has 150 ppm of calcium ions. What mass of calcium would be found in 250 grams of Perrier? Well, we take a look at our formula. We know that part per million. So ppm equals mass of solute divided by mass of solution. times 10 to the 6th. So we have 150 equals mass of solute. Our solute is calcium. This is our solution. So we're going to have our mass of calcium, let's just call it M, divided the mass of solution, 250, and times 10 to the exponent 6. So I'm going to do 150, I'm going to divide by 10 to the 6th, and I'm going to end up multiplying by 250. So I'm combining two steps at once. Whichever way you're comfortable with the algebra, find a way that is consistent and that works for you. So I have 150, I'm going to divide by 10 to the exponent 6 to the 6th, and then I'm going to divide by 250, and I get 0.0000 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6 grams of calcium. 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. I hope that was helpful.